In this section, we're gonna cover farsightedness, or its name Hyperopia. And this problem, it is the same with the previous problem, except this time I just changed the nearsighted to farsighted. So everything keeps the same except this time, since it is farsightedness, a person could not see things that is close to them. So I put an arrow with a distance s. So we're trying to express f1, which is the focal length of this lens, in terms of L, W, delta x, and s. I forgot to put s here. For a farsighted person, they have a larger near point, which means that normal person have a near point of 25 centimeters. They have a near point greater than 25 centimeters. So that means that if s is, let's say, is 10 or it's 25 centimeters, then the problem cannot see the image. So the eye's lens refract the light rays too little. That means that the image is formed behind the retina. And it would be a blurry image, and the lens acts as an accommodation to increase the power of the eye's lens. So that means the glasses is a converging lens. So f1 would be positive. So consider looking at the object with glasses. We have this nice ray diagram showing everything. We first look at the first lens, the glass lens. And we assume that the glasses is thin lens, so we could use the thinness equation. And then we have a image distance written in terms of the focal point, the focal length and the image distance. And we assume that the eye's lens are also thin lens, so we are looking at the second image. We apply the same thing, the same equation here, and we get this equation. So when we're looking at this equation, we're very close to our answer, except f2 is not written in terms of the variables we have. So we have to consider the case where we look at the object without glasses. So the image is formed behind the retina. And when we write the equations, we know that we could write f2 in terms of the s1 prime, L, W, and delta x. We could express s1 prime in terms of f1 and s. So after some very tedious algebra, we have the final answer. And this explains what a farsightedness people see, and what exactly is hyperopia.